The following question, there's an equation given where you have Fe2O3 reacting with 3CO and it's producing iron and carbon dioxide. You're given the mass of iron 3 oxide and you're given the volume of gas carbon monoxide, which is 200 dm cube, and you're being asked to find the mass and the volume of gas in the products. The first thing that you're going to do is you're going to find the moles of Fe2O3. Moles can be found, since mass is given, it can be found using mass divided by the MR. So mass is given, but it's in kg. You need to calculate the mass in grams, so you need to multiply that by 1000. So it's going to be 1500 grams. The MR of Fe2O3 is going to be 55.8 is the AR relative atomic mass of Fe. So there are 2 irons in it. So that would be multiplied by 2. Plus there are 3 oxygens, so that's 16.0 multiplied by 3. And if you try and solve this on your calculator, the value that you're going to get is, so this over here is the value that I'm getting on my calculator, which is, and there are lots of trailing decimal places in the value. Remember, your value is, the mass was accurate up to 4 significant figures, whereas the relative atomic mass in the periodic table were accurate up to 3 significant figures. So remember to use the least significant figures. So I'm going to round it off to 3 significant figures, which would make the value equal to, it would be rounded off at 9. So this value, when you're going to write this value, it's going to be 9.40 moles. So these are the moles of Fe2O3 that you have. Then you can find the moles of carbon monoxide. Remember, it's the gas. So for gases, moles can be found using volume of gas divided by the molar volume, which is accurate up to 3 significant figures. So it's 24.0 dm cube. And if we solve for it, it's going to be 200 dm cube, and you have to divide that by 24.0 dm cube, which is the molar volume, and the answer that you're going to get is, so my calculator shows 8.33, it's recurring 3, so 8.333 moles, and one of your values is accurate up to 3 significant figures, the other value is accurate up to 4 significant figures. So your answer would follow the least significant figure value, so it has to be rounded off to 8.33 moles. So when you're stating the answer, round it off to the appropriate significant figure, but when you're doing the calculations and in every step, make sure you don't round this value in your calculation. So any step that we follow, which is followed after this step, remember to take the most accurate value forward on your calculator. So I've gotten the moles of the 2 substances. So 9.40 moles for Fe2O3 and 8.33 moles for carbon monoxide. Now, what if the value is in excess? I need to figure out which one of the value is in excess, which one is the excess reactant. So the simple method of finding which one is in excess is 9.40. You're going to take 9.40 moles and divide it by the ratio in the equation, which is 1. And you're going to do the same for 8.33 moles. Divide that by the ratio in the equation, which is 3. And you're going to figure out which one of the 2 values is the bigger value. In this case, the bigger value comes out to be this one. So that indicates that your value for 9.40 moles is in excess. It's a lot more than the required amount, and you're not going to use these moles in your calculations because not all of the moles are taking part in the reaction. So these are your excess moles, and you're going to ignore your excess moles. You're going to take all your calculations further on. They would be using these moles, the limiting reactant moles. So 8.33 moles are the ones that are completely taking part in the reaction. So when you're going to find the moles of Fe and CO2, use these moles 8.33. Now using 8.33 moles, I'm going to try and find the moles of carbon dioxide, the moles of iron. Carbon monoxide and carbon dioxide have exactly the same ratio. It's 3:3, which means if you have 8.33 moles of carbon monoxide, then the moles of carbon dioxide are going to be exactly the same. So it's going to be 8.33 moles. Remember that on your calculator, this should be a recurring 3. And I can use ratios to find the moles of Fe. 3 molecules of carbon monoxide produce 2 Fe. So the ratio is 3:2. So 8.33 moles, if you have carbon monoxide moles, that's 8.33. How many moles of Fe would be produced? So using ratios, 8.33 is going to produce X. And I can cross multiply, my X would come out to be 2 multiplied by 8.33 divided by 3. And remember, when you're solving this in your calculator, use a recurring 3 over here. And my answer in this case is it's coming out to be 5 now I am getting a recurring 5.55 moles. So if I want to state this answer, it's going to be 5.56 moles. So I now have both moles of my reactants. I need to find the mass of Fe. So that is simple. We can use the formula, which is mass is moles multiplied by the AR in this case. So it's going to be 5.56 multiplied by the relative atomic mass of Fe, which is 55.8. Remember to use in your calculation, remember to not use this rounded value, but instead use 5.55, which had a recurring 5 in it, in your calculation. So on your calculator, the answer that you're going to get is, so I'm getting 310 grams. And this would be accurate up to 3 significant figures, because both my values are accurate up to 3 significant figures. So it's 310 grams, and the same we can do for this. We need to find the volume of gas. Volume of gas is moles multiplied by the molar volume, which is 24.0 dm cube, accurate up to 3 significant figure. So let's try and solve this, and it's going to come out to be equal to exactly, remember to use this recurring 3. So it's going to be 8.33, and it's going to be a recurring 3 multiplied by 24. So the value would come out to be rounded off to 3 significant figures. It's going to be 200 decimeter cube on your calculator. So these two would be my answer to the question.